6.2, continuing on from what we did yesterday, we are adding and subtracting with radicals now. Remember the radical are these symbols right here. And so since we're doing that, your solutions today, I want you to put them in radical form. In order to add or subtract radicals, you need to have the same radicand. If you remember from our vocabulary earlier, the radicand is whatever is underneath of the radical. You also need to have the same root index. So in this case, that would be the 4. So whatever roots you're taking, those have to be the same. Think about it a lot the same as what we do with variables. You can add them if they are like terms. So both the radicands and the root indexes are the same. Then, if there's nothing there, you assume it's times 1. So if I have 1 times the 4th root of 10 plus 7 times the 4th root of 10, I add 1 plus 7. I get 8. The 4th root of 10 stays the same.
Wait, I'm confused.
Okay, you look for like terms. So I've got the 4th root of 10 here. Oops, not that.
Oh, wait, okay, now. Yep.
4th root of 10 here, 4th root of 10 here. So that stays the same. I have a 1 plus 7 makes 8.
Yep.
Okay? So now if you look at the next one, I have the square root of 2 plus the square root of 3. I add those together. I don't have the same radicand, so I can't simplify that anymore. You need to just, that is your answer. You can't simplify that further. They have the same root index, which is the square root, but they have a different radicand, so you can't simplify it anymore.
I thought the radicand was the 4.
Okay, that's the root index. The radicand is the one underneath. So the 2 is a radicand and the 3 is a radicand. Okay? Now, when you first look at this next one, I have the cube root of 54 minus the cube root of 2. You would initially say, well, I can't combine those, but I can simplify the cube root of 54. We talked about this a little bit yesterday. We had it on there. So what you want to do is simplify this. So let's see, 2 goes in there 27 times. 27 is 3 times 9, which is 3 times 3. And if you just recognize that 27 is a cube root, that's okay too. So 54 is 2 times 3 to the 3rd power. So I'm going to write this as the cube root of 3 to the 3rd times 2. And this is still minus the cube root of 2. Well, if the 3 here matches a 3 there, they cancel each other out, so I can move that 3 to the outside of the radical sign. So I have 3 times the cube root of 2 minus the cube root of 2. Now I have like terms. The root indexes are both 3. The radicands are both 2. So I can say 3 minus 1 is 2. So I have 2 times the cube root of 2. Okay, questions on that one? So simplifying under the radicand is really important to make this work. See if you can combine them. Okay, so now I have the square root of 50 plus the square root of 18. So again, if you don't see it right away, you can do the prime factorization with this as well, or you can look at it and say, what perfect square goes into 50? 25 times 2. Plus, what perfect square goes into 18? 9 times 2. Okay, so the square root of 25 is 5. So I have 5 root 2. The square root of 9 is 3, so I have 3 root 2. I don't know why I'm keep insisting on writing 3. And now I I have like terms, so I can take 5 plus 3 is 8, and I get 8 root 2. Make sense? Okay. Now we've done this kind of thing before a little bit. This time we're just adding cube roots and fourth roots, that kind of thing, to what we've already done before. So let's look at some other examples. Some of these are a continuation from what we did yesterday. If I have x to the 1/2 times x to the 1/3.
That's 1.
So now, be careful. If I have like bases, I need to add the exponents. 1/2 plus 1/3. So just like we did on the one I did over here, we need to find a common denominator, which is going to be 6. So to get 6, I need to multiply top and bottom by 3. So that's 3 6 plus multiply top and bottom here by 2 to get 6. So I get 2 6. So 3 6 plus 2 6 is 5 6. I get x to the 5 6 power. Questions? Yes.
How did you get 3 6 and 2 6?
Okay, from when I have to add two fractions, I need to get a greatest common denominator, so I know it's going to be 6. So to get 6 here, I need to take the top and bottom times 3. So that makes 3 6.
Okay, I got it.
And 2 there, okay? Any other questions on those? Okay, let's look at this next one. Now, anytime you have a number under the radical, the first thing you want to do is, well, if you just look at it and recognize some perfect root, that's great. Just go right ahead and do it. If not, let's do a prime factorization. So now, when I do a prime factorization, the first thing I do is I think, okay, is it even? If it does, 2 will go in there. If it's not, no even number is going to go into it. So that eliminates 2 and all the even numbers. Next, I look at it and I add the integers together. So I say 2 plus 4 plus 3 is 9. If that's a multiple of 3, then 3 will go in there. 3 will go into this one. So if I have 3 times 81. Now, if you recognize 81 is a perfect fourth root, but if you don't recognize that, you know 81 is 9 times 9, which is 3 times 3. So I have 243 is 3 to the 1, 2, 3, 4, 5. So I'm going to rewrite that this way. So I have the fourth root of 3 to the 5th, x to the 5th. Now, if you look here, and this exponent is higher than this, then I can get some part of that outside of the radical. So I'm going to rewrite it this way. So I have 3 to the 4th times 3. Because that's 3 to the 1. 4 plus 1 is 5, so I can break it down that way.
Where's the other 5?
Okay. 3 to the 5th, all I did was rewrite it this way. If I combine it back together, it'd be 3 to the 5th. Okay? Now the reason
I get it.
I broke it apart is because I want to try and make those two match. Okay? So now I look at the ones that match. This 4 matches with that 4, so that 3 can come to the outside of the radical. This one over here, I have an x to the 4th matches with that 4, so that x can come outside the radical. Now whatever's left has to stay underneath of the radical. That is the simplified version in radical form. Okay, so if you're given something in radical form, I want you to give me your answer in radical form. If you're given something with fractional exponents, you can give me your answer with fractional exponents. So with this one, now we're going to look at your tests today. when we get done with this. One of the things that I noticed on your test is people are having trouble with those negative exponents. Now you can attack this one by simply subtracting your exponents and going from there. I'm going to deal with the negative just to help you get practice as to where things go. The only negative exponent in this case is b to the negative 1/2. That means that is the only thing that will have to move from the denominator up to the numerator. So I'm going to rewrite this without the negative exponent first. I have a to the 1/5 times b. Now, since this is a negative exponent, just that part is going to move up to the top.
But isn't that b on the top represent 1?
Yeah, so this
So
is,
if you went 1 minus a half, it would be 1.
you're going to get the same answer, yes. I'm going to do it this way just because I know there's people struggling with how those move around, but yes, you could do it and do it that way as well. You'll get the same answer. And this is still over a. Does everybody see where how that works? Okay, so now I have, look at all my a's together, and I can say 1/5 minus 1. So this is a to the 1/5 minus 1. Now these are multiplied, so I have b to the 1 plus 1/2. Now, so we subtract 1/5, a to the 1/5 minus 5/5 is going to give me a to the negative 4/5. b to the 1 plus 1/2 is b to the 3/2. Now,
Could you ever write it as mixed numbers or no?
no, you're not gonna. Don't ever write your exponents as a mixed number. Leave them as, because they mean something in this form. This means I'm taking the square root and then raising it to the third
How
power.
do you get 3 f's?
1 plus 1/2. So that's
So that's 3/2, Bob.
Yeah.
3/2.
like that. Okay, that's okay. And if you need to rewrite those with their common denominators, by all means do. If you can look at it and remember that's what it is, that's fine too. Okay, so now I'm not quite done. I need to write this without any negative exponents. So just this part, that a with the negative exponent will go to the bottom of my fraction. So I have b to the 3/2 over a to the 4/5. Like I said, if you were given fractional exponents to begin with, then you can write your answer with fractional exponents. If you're given radical to begin with, write your answer in radical form. Okay. Now I have the 4th root of 1 over 4. Now, I want you to, if this is given in radical form, I want you to write this without any radicals in the denominator. So the first thing you're going to do is break that into parts. So I have the 4th root of 1 over the 4th root of 4. Well, the 4th root of 1, that's easy. Like those. That's just 1. Now, in order to get rid of this radical in the denominator, I'm going to write this in prime factored form, and here's why. This is the 4th root of 2 squared. In order to make that radical go away, I need to make that exponent be a 4. Has to match this. So what can I take 2 squared times to make that a 4?
2.
2 squared again, right?
Yeah.
Okay. So I remember to make this follow the rules, you have to take it times 2 squared, or the 4th root of 2 squared over the 4th root of 2 squared. This is equal to 1, so when I multiply it by the first one, it still is following all the right rules. So on the top, I get the 4th root of 2 squared. On the bottom, I get the 4th root of 2 to the 4th. Like bases, add their exponents. They're both under the 4th root, so I can multiply them. Now, this 4 and this 4 match, so they cancel each other. So on the bottom, I'm going to have just 2. Now, this thing on the top, I'm going to work on the side here for a minute. I'm going to rewrite this with fractional exponents so you can see what I'm going to do here. This is 2 squared to the 1/4. When I take 2 times 1/4, I get 2 to the 2/4 power, which is 2 to the 1/2. 1/2 means the square root. So this is the square root of 2 over 2. Now, if you're thinking and you look at this, and hopefully the practice yesterday helped you to see this a little bit. This is actually 2 to the 2/4 power. If that fraction can be reduced, that turns it into 2 to the 1/2, which you know is the square root of 2. So if you have this fractional exponent can be reduced, do that. Okay? Questions? Okay, let's keep going with some more. The cube root of 64, y to the 6th. Okay, first off, the cube root of 64, you should know that one by now.
4.
That's 4. So that's 4. Now the easiest way to simplify inside of here,
Why the 6, that's 3.
item 6 to the 1/3. 6 times 1/3
Is 2.
So I have 4y squared. Now, if this was still a fraction, I need to put it back into radical form, but since it's not, I'm done. Okay? Next one. 27 p to the 3rd, q to the 4th, all to the 1/3 power. If it's to the 1/3, what root am I taking?
3rd.
Cube root. What is the cube root of 27?
3.
So this is 3.
Cube root of p. Cube is p.
Okay. And actually, I'm going to write out another step in here, just so everybody gets this. So this is 27 to the 1/3, p cubed to the 1/3, q to the 12th, to the 1/3. So the cube root of 27 was 3. 1/3 times 3 is 1, so that's p. 12 times 1/3 is 4, so that's q to the 4th. Okay, so make sure if it's all in parentheses, everything in there is raised to that power. Okay, this last one. Now there's a couple of ways to attack this one. First thing you need to check, does 4 have an even 5th root? It's 2 squared, a way to get an exponent of 5, so you know that's going to have to stay underneath of the root here. So actually I'm going to rewrite this with fractional exponents, and then we're going to put it back into radical form. So I've got 4 to the 1/5. We've got a, and here's how you write this, 8 over 5. B to the 14 over 5. And C to the 5 over 5. Now, if you're one of those people that can visualize these without doing this particular step, that's okay. If you're not, make sure that you do that. Now, I'm going to try and set these so that they have exponents of 5. So 4 to the 1/5, that's going to stay under the root. Now a to the 8/5. Okay, this is a to the 5/5 times a to the 3/5. Does everybody see what I just did?
Yes.
Okay, 5 plus 3 is 8. I want to make this into a 1. Okay?
Why?
Because that's going to be outside the radical when I'm done.
Wait, you don't have radical.
I will have it. We're going to put it back in radical form. Okay? So this is b to the, now I'm going to use a multiple of 5 to the 10/5 times b to the 4/5. This is going to simplify to 2. And the last one, we can just say c is c to the 1. Now, the reason I did this, 4 to the 1/5, a to the 1, a to the 3/5, b to the 2, b to the 4/5, c. So now, we put it back in radical form. I'm going to take all the ones that are to a whole, to an integer power. So that's going to be this one, and this one. They go outside the radical. So I'm going to have a b squared c. Now I'm going to write the radical. The 5th root of everything with a 5 in the denominator goes back under there. This is 4 to the 1 or just 4. A to the 3rd. And this was 5. So b to the 4th. That's in simplified radical form. Okay, another way to look at that, if you go straight from here, you say 8 minus 5 is 3, so I'm going to have an a on the outside and a to the 3rd on the inside. 14 minus 5, or 14 divided by 5, it's going to have 10 with 4 left over. So that's 2, and 4 underneath up here, and I missed my c, so he has, no, my c is here. 5 divided by 5 is 1, so the c goes out here. You're done. Okay, on your worksheet today, you have a few problems that have decimal exponents.
Can you just times by 10?
No, you can't, but you just add them. So x to the 1.5 times x to the 2.5 is just going to be x to the 1.5 plus 2.5. When you add those together, we get 4. So that's just x to the 2. Okay, so I have some things to practice. I'm going to hand out these worksheets, and then actually somebody wants to hand out the worksheets. I will pass out tests. I'm not going to go over it.
How were the tests overall?
I had a variety.
Oh, man.
In this class, I had
How many F's?
A's. Let's see, in this period I had 2 A's.
How many?
I had Cruz and Corey for my A's.
Let's round them
In this class, I had 3 F's.
Oh, wait.
I didn't put grades on these, but remember 90s are A's. Or some of them I did, some of them I did. 90s are A's, 80s are B's, 70s are
Yeah, you did.
60s are D's.
You tried hard. You doing both sides, Steve?
Yes. So, while you're working, I'm going to hand them out. I am not going to go over these one term at a time, but I did make quite a few notes in here, so look them over. Ask me questions if you have them. And you can go ahead and get started on your worksheet while I'm getting them handed out. Worksheet.
He said worksheet.